Hello guys, welcome to Tech Design. Hope everyone is doing great. So in this tutorial I'm going to show you how we can make assembly of this universal joint. So in the previous tutorials we have discussed how to model each and every component. So only one component is left, that is cross bearing. So I'm going to do the modeling of that cross bearing today, and then in this same video I'm going to continue with the assembly. So please stay tuned and subscribe to my channel, hit a like button as well as share my videos. So now let me go to new file. So here is a new file, and I will just give cross bearing. So this is the last part. So once this part is created, we will just go to an assembly, how we can make an assembly. So in this one, what I will do is I will just go to sketcher environment, and you can select any plane to go to sketcher environment, and you can just click OK. So now here I'm going to draw a simple profile here. So let me go to this profile. Okay, so let me hide these auto dimensions, and I will hit E and I will extend this, and let me trim this extra portion. And now let me constrain it by using a C command. So this point on a curve, so this point should be on this curve, so they should lie in the same line. And now what I will do is I will just go to and geometry, make symmetry. So these two should be symmetric to this x-axis, as well as these two should be symmetric to this x-axis. So now let me give an okay, let me see. Okay, this line should also lie on this y-axis. So press C. So point on a curve, so this point should be on this curve. Okay, so now all the the geometric constraints are done. Now we have to give a dimension for this. So press D for dimensioning. So this overall length is 254.10. okay, and fit this now. Now whatever this dimension, it is 147.8. okay, and the distance between this to this, it is 44.55. okay, and then I'll just close this and let me move this inside. Okay, so now the distance between this to this is 24.30. okay, so now as you can see here, our sketch is fully constrained. So that's all we have this in this sketch. So we can just finish this sketch, and now you can see here we have a profile, and I'm just going to revolve this. So go to revolve and select this sketch, and my vector will be along this direction. So now as you can see here, we got this profile. So we'll just click OK now. So now what I will do is I will just go to pattern. So I'm going to pattern this feature. So go to menu, insert, and associative copy, and here is our pattern feature. So I'm going to pattern this whatever the feature we have, revolve feature, and it should be circular pattern. Okay, and my vector will be along this direction. Okay, and the point will be, let me give a point here. Okay, at 0, 0, 0. And now we need to provide a count and a pitch. So what I will do is I will just provide okay, let me hit count. So the two counts, and the pitch will be 90 degree. Okay, let me see. Okay, see how this looks. So this is what we need. You can just click OK. So now we have two features here. This is the one feature, and this is the another feature. So we are going to unite them. So this should be united with this, and I can just click OK. So now what I will do is I will just go to sketcher environment again on this plane. Okay, and I'll just click OK. So now what I will do is I will just draw a simple rectangle here. So this is my rectangle. So this is for construction purpose only. So I'll just make symmetric. So these two lines should be symmetric to this, and these two should be symmetric to x-axis. Okay, so let me give a dimension for this. So this is 118.24 and this is also same, so 118.2. okay, so this is a complete square. And now what I'll do is I'll just draw a circle here. So this is my circle which is at, okay, let me draw here and just give tangency. So these two should be tangent. So this should be whatever these curves should be construction lines. So I'm going to make them as a construction lines. Select all these curves and make it as construction line. Okay, so now we have one circle here, so we just need one more circle. So this is my another circle. Okay, so now let me give the dimension for this. So hit D and we have a dimension of 70.94. okay, so now as you can see here, our sketch is fully constrained, so we can just finish the sketch. So now what I'll do is I'll just go to extrude and I'll just remove the whatever that is selected here. Okay, extrude, and now we'll just keep it as a static wireframe, and I'm going to select this outer circle. So let's just go to single curve and select this. Sorry guys. Okay, so now let me give a dimension here. So this is 106, so 106 by 2, sorry, 106. okay, so now what I'll do is it should be united with the body, so just give unite and you can just click OK. So as you can see here, we got this. And now what I will do is I will just make the same way. I am going to remove the material. So for the removing, I am going to select the inner circle and let me keep it as an symmetric value, and you can just extract it. It is a subtract and you can just click OK. So now we got this profile. So now what I have to do is I will just provide some chamfer for this. So go to chamfer here, and the value will be 2.8 and 45 degree. So we need to select all these curves. Okay, so now as you can see here, our model is ready. So this is a cross bearing. Hit Ctrl W and hide everything and show only solid bodies. And now we can save this. Okay, so now this cross bearing is saved, so all the components are already saved. Now we have to make an assembly for this. So for that, what I will do is I will just go to new file. So go to new file and I'll just select assembly here, and this I will just provide universal joint. Okay, and I'll just click OK. So this is our assembly file. So as soon as you load this create this assembly file, it is asking for us to add a component. So either you can add it here or else we have another option to add. So now what I'll do is I'll just select all these 4 items and I'll just click OK, and let me add these files. Okay, so as you can see here, all these files are added. So what I'll do is I'll just provide an color for this. And save this, and now go to here and give this as well. Okay, so now we got all these items. So what we have to do is we have to fix any one of the components. So let me go to here and add position. So the position will give you whether the component is completely fixed or it is having degrees of freedoms. So let me hide all these things. So first of all, I am going to assemble and fix this yoke. So in order to fix this, you can just go to assembly constraints and select this fix constraint and select the component, and you can just click OK. As you can see here, you can see this component is completely fixed. Okay, the first component you just need to fix it in order to arrest all the degrees of the freedom. Okay, so once this is fixed, we need to add a sleeve. So as you can see here, this is a sleeve. So this sleeve should be added over here. So what I will do is I'll just go to assembly constraints. So go to assembly constraint, and I will just go to preferred touch. So in the preferred touch also we can make a concentric, or else you can just go to center line axis. So go to center line axis and select this center line and this center line. So now as you can see here, both the center lines are aligned. So if you want to move it, you can just move it along that axis in order to make it clear. So now as you can see here, this is movable. Okay, so now so this component is completely movable along this direction. So what I'll do is I'll just go to assembly constraint. So we'll just make an align lock. So this should be align locked with this. Okay, you can just click OK. So as soon as you do lock, so it will lock the rotation along this axis. So we are already discussed on align lock. So if you have not checked my assembly tutorials, you can just go to there and check it out. Okay, so now I'll just go to assembly constraints and I'll just give a distance. So there should be some distance between this to this face. So now it is 308. So let me give 35 mm. So and I can just click OK. So now as you can see here, there is a distance of 35 mm and this component is completely constrained. So now as you can see here, these two components are properly aligned. Now we need to assemble a cross bearing. So as you can see here, this is a one cross bearing. So we just need the two components of cross bearing. One is over here and another one is over here. So let me copy it later. First of all, let me assemble this part. So I'll just give assembly constraint here, and here I'm going to go to again center line axis. So whatever this center line should be aligned with this center line. Okay, so once it is aligned, you can just have you can just move it. So I'll just click OK and hit move command and move it to its location. Okay, so once it is moved, okay, and also it should be along this direction. Okay, later we can just give an angle. First let's move it to a proper location. So now as you can see here, this is completely aligned with this center line, but the case is it is not exactly at the center. As you can see here, the distance over here is more and then the distance here is less. So in order to completely center, make it as a center, so go to assembly constraints and you can see here center, and now we have to select 2 to 2. So these things are already explained for you, and you can just go to my tutorial to check that. So now what I'll do is I'll just select two faces over here and two faces from this. Okay, so as soon as you give this, as you can see here, the distance between these two will be same. Okay, so now as you can see here, this is not fully constrained. You can just see what are the degrees of freedoms. So as you can see, the rotation along this axis is still active. So we just need to give align that. So in order to do that, what I will do is I'll just go to assembly constraints and I'll just use make a parallel. So you can see here, make parallel. So I'll make this face should be parallel to either this face or this face. Any face you can just make a parallel so that it will restrict the rotation of that component, and you can just click OK. So now as you can see here, our cross bearing is completely constrained. So this is how we can make a constraint of any component, guys. So now what I will do is so now the same component I just needed on this item position as well. So in order to do that, I'll just go to select this cross bearing and Control C and Control V. So as soon as you do this, you can see here it is multiplied by 2. It means that it is 2 components. So you can right click and unpack it. So once you unpack it, you can see here this component is completely constrained, but this is not constrained. So we just need to move this, and let me move it over here, And now what I will do is I'll just make the same thing whatever we have done for this. So go to assembly constraints and go to center line axis. So this center line should be with this center line. So now even though it is having a center line distance, it is exactly at the center, we just need to provide an center line align, because we need to restrict the rotation along this axis. So go to 2 to 2 and select these two faces and with these two faces. Okay, so now it is done. So now as you can see here, this is partially constrained. So let us see the degrees of freedoms. So the same thing, it is rotated, it is having a rotation along this axis. So what we'll do is we'll just make a parallelism the way how we have done in the last case. So go to parallel and select this face. Now either you can select this face or we can also select this face. So let me give this face. Okay, you can just click OK. So now this is also completely constrained. So there are two cross bearings we need. We can just pack it. Packing will avoid scrolling down if you have a huge assembly. So always keep a similar component packed so that it will be easy for you. So now we have a flange here. So this is our flange. So where is that? Okay, here. So we just need to bring it over here and then assemble it. So I'll just go to move component and I wanted to move this. So now I'll just move it over here. So let me switch on these. Okay, so moved. So let me make it an okay. So now what I have to do is I'll just click OK. So whatever this center line should be center lined with this one. So let me go to assembly and go to center align axis. So this center line should be with this. Okay, so okay, now let me move this component down a little bit. Move component and move it down. Okay, so in the same way, whatever how we have done for this align between to keep it as a center line. So go to assembly constraint and use a center, and let me select these two faces first. Okay, this face and then this face. So it should be centrally aligned. Okay, now it's done. So now you can just check whether which degrees of freedom is active. As you can see here, along this Z axis there is a rotation for this component, so we need to fix that. So either you can just give a parallelism for that, or else you can just provide an some angle between those two. So let me give assembly constraints and we can just give an angle between this face and I'm going to give this face. So what is the angle currently? It is 156. So let me reduce it to 50. Sorry guys, 175. So 175 is also good number. As you can see, we don't have any interference here. Since this is an universal joint, it can be movable along this direction. So let me give some 170. 70 is also good. Okay, so now we can just click OK. So now as you can see here, this flange is also completely constrained. So in the same way we have to do it on this side as well. So I'll just do Ctrl+C copy and Ctrl+V paste and unpack this. So this we are not going to touch because this is completely constrained, and we are going to move this assembly constraints. And now what I'll do is I'll just go to central and aligned. So go to here and central and this. Okay, sorry guys. So now we need to move this, otherwise we don't get whether which component it is selecting a center line. So we can just move it over here. Okay, so now we can go to assembly constraint and select this center line and this center line. Okay, so move it around this direction. Okay, Yeah, so now we have to provide an center constraint. So go to here and give this center. So two faces should be selected from the same component, and then the other two should be selected from the other component. So now as you can see here we cannot able to pick this surface. So in that case what we can do is you can just go here and right click on this, select from the list, and you can see this face you can select. So same way, right click, select from the list and this face, and you can just click OK. So now this is completely center aligned. So now as you can see here, only along this Z axis there will be a rotation for this. So if you want, I'll just show you. As you can see here, along Z axis there is a rotation. We need to fix that. I'll just give an parallelism for this face to this face. So go to assembly constraint and parallel. So this face should be parallel with this, and just click OK. So now you can see here all the components are completely fixed and completely constrained. So it means that our assembly is ready. So either we can just I'll just hide all these constraints. You can just right click on these constraints and you can just hide them. So now whatever the blue lines, whatever the constraint we have, everything will be hidden. So if you want to show them, you can just show them here, or else if you want to show individual items, you can just show it individual items over here. The one more important point over here is, say for example you want to delete any constraint that is having a restriction. Say for example there is an yoke here, flange here. So this flange is having an aligned with this center aligned with this component. So in order to check that, you can just select this and go to dependencies, and here are the dependencies. So you can just give this detailed view. So once you give detailed view, there are three constraints we have given for this component. So these are the three flange. Okay, these are the three constraint we have given. So as you can see here, there is an angle between the cross bearing and flange, and there is a center line which is flange between the cross bearing, and then touch between the flange and the cross bearing. So if you want, you can just remove the constraint you want, and then you can just mention any other constraints. So this is how this assembly tutorial works, guys. So hope you enjoy this tutorial. Please subscribe to my channel, hit a like button, as well as share my videos. Thank you, guys.